Hello everyone! Welcome back once again to DOK GILMAC Online Tutorial. The topic I will be discussing for today's tutorial is all about angles of elevation and angles of depression. Before discussing the topic for today's tutorial, let's have first a warm-up drills. Number 1. Solve triangle ABC where C is equal to 90 degrees. A and B are acute angles. Sides A and B are the lengths. And side C is the hypotenuse. Round off your answers based from the given sides and angles. Angle A is equal to 35 degrees. Side A is 4.5. Side B is unknown. Angle B is unknown. Side C is unknown. Solving for side B, we have here tangent A is just equal to opposite over the adjacent side. Or that is, tangent of A is A over B. Wherein B is just equal to A over tangent of A. Or that is simply B is equal to 4.5 over tangent 35. Solving this in a scientific calculator, B is equal to 6.4. Now, solving for angle B, B is just equal to 90 minus 35, which is equal to 55 degrees. Now, the question is, why did B subtract 35 from 90? Take note, A and B are both acute angles, and A and B are also complementary angles. So, B is just equal to 90 minus 35 degrees, so which is equal to 55 degrees. Solving for C, we have sin A is just equal to A over C, or that is, sin A is opposite over the hypotenuse. Wherein C is just equal to A over sin A, or C is equal to 4.5 over sin 35. Solving this in a scientific calculator, C is just equal to 7.8. Number 2. Solve triangle ABC where C is equal to 90 degrees. A and B are acute angles. Side A and B are the lengths and side C is the hypotenuse. Round off your answers based from the given sides and angles. Side A is 16. Side B is 30. Angle A is unknown. Angle B is unknown. Side C is unknown. Now, solving for angle A, we have here tangent A is equal to A over B. Or A is just equal to tangent inverse of A over B. A is equal to tangent inverse of 16 over 30. Solving this in a scientific calculator, A is just equal to 28 degrees. Now, since A and B are complementary angles, we can determine angle B by getting the difference of 90 and 28 degrees. So, B is just equal to 90 minus 28, where B is just equal to 62 degrees. Solving for C, side C, where here cosine A is just equal to B over C, or cosine A is just equal to the adjacent side over the hypotenuse. So from here, we can say that C is equal to B over cosine A, or we have here 30 divided by cosine 28. Solving this in a scientific calculator, we have here C is equal to 34. What is an angle of elevation? The angle of elevation is the angle between the imaginary line of sight and a horizontal line, where the object is above the observer. So as you can see here, this is the object is the sun, and the observer is actually below the object. Okay? What is an angle of depression? The angle of depression is the angle between the imaginary line of sight and a horizontal line where the object is below the observer. So as you can see here, the observer is on the top of this object, and take note, the ball is actually the object here, which is just below the observer. Now let's have an illustrative example. Example number 1. The angle of elevation of the sun is 20 degrees. If the building is 50 meters high, then how long is the shadow cast by a building? So as you can see here, the object here is the sun, and the angle of elevation is 20 degrees. The height of the building is 50 meters. So solving this, we let S be equal to the shadow of the building. So using tangent function, tangent 20 degrees is equal to 50 meters over S, wherein 50 meters is the opposite of the angle of elevation, which is 20 degrees, and the adjacent side is S. So from here, we can say that S is equal to 50 divided by tangent 20 degrees. Solving this in a scientific calculator, S is just equal to 137 meters. Example number 2. Find the height of a hot air balloon, which is directly above a nipa hat, if the angle of depression of a carabao 62 meters away from the nipa hat is 14 degrees 55 minutes. So as you can see here, the angle of depression is 14 degrees and 55 minutes. The observer is above the object, which is the carabao. Take note, if we draw a horizontal line here and a right triangle, we can come up with this angle here that is just equal to this angle. They are both alternate interior angles. In geometry, alternate interior angles are equal. So we have here 14 degrees and 55 minutes. Now, solving for the height of the hot air balloon above the level ground, we let h be equal to the height of the hot air balloon. Using tangent function, tangent 14 degrees, 55 minutes is equal to h over 62, where h is equal to 62 times tangent 14 degrees, 55 minutes, which is just equal to 16.52 meters, approximately equal to 17 meters. Again, I would like to thank you for watching and stand by for my next tutorial. May God bless us all.